In this illustration, we'll analyze the tension in a supporting cord. Here we are given that the figure shows a solid block of volume 1000 cm3 and density 0.8 gram per centimeter cube submerged in a liquid of density 1.2 gram per centimeter cube and tied to bottom with a cord. Here it is saying if container is accelerating up at 5 meter per second square, then we are required to find the tension in this cord. So in this situation, first we can draw the free body diagram of this block, on which in downward direction the force will be tension plus mg effective, where we can write the value of g effective is equals to g plus a, as the container is accelerating up with acceleration a. So here we can write the value of g is 10 meter per second square, and if we take the acceleration which is given as 5, so it will be 15 meter per second square, and in upward direction the block will be experiencing the buoyancy force. So here we can write for equilibrium of block in frame of container. Here we use, in this situation, buoyant force is equals to T plus mg effective. So here the value of tension we'll be getting is buoyant force minus mg effective. Here if we substitute the values, the buoyant force can be given as V rho g. Here we can solve it in CGS units, as the volume of block is given as 1000 centimeter cube. So buoyant force we can write as V rho g minus mg effective, and here the volume is 1000 multiplied by the density of liquid we are given with 1.2 gram per centimeter cube. This is 1.2, and the value of g here we can again take as g effective only, because with respect to container the buoyant force will be acting with respect to effective gravity. So effective gravity here we can take as 1500 minus the mass of block, we can again substitute as the volume multiplied by its density. So this is 1000 multiplied by 0.8 multiplied by 1500. So numerically when we simplify, this will give us 6 into 10 to power 5 dyne, the force acting on it, and we convert it in SI units. This will be 6 Newton. That is the result of this problem.